We want the moment around, in this case, it's also called point O. Which is conveniently also at the origin. So we have this pipe that starts at the origin and then goes along the x-axis and then goes down and to the right. And that's our point A. And then we have two forces, F1 and F2, acting at that point. And we already have the forces in component form, so we don't have to go that extra step for this problem. And since we have a 3D drawing, it's going to be helpful if we give its coordinates. So what would the coordinates of point A be for this problem? Okay, so 3 in the x. In the x, if we go from the origin forward, we have to go 3 to get to A. So it's sometimes a little tough to read. In the y, right, so it drops down below the xy plane. So then in the y direction, we have to go 2 to get to that bend in the elbow, but then we have to go another 1 to get to A. So A is going to be also 3 in the y.
-2.
Right, and -2 in the z direction. And that's all in feet for this one. Right, so that'll make it more convenient when we go to find our position vector, because our equation is going to be the same. The moment around O is now going to be, we have two forces, so the moment around O is going to be the moment contribution from force F1 plus the moment contribution from force F2. So it will turn out to be ROA cross F1 plus ROA cross F2. In general, these are usually not going to be the same position vector, since F1 and F2 will usually be at different places, but it's whatever. We start at O and we go to where this is applied, point A. We start at O, we go to where this is applied, which happens to also be point A. So the next step, each of these cross products is going to have its own determinant that we need to solve. ROA is going to be point A minus the origin. That's 3, 3, -2. This will be in feet. So for the first one, we put in the components of F1, which we were given, -20, +10, 30 pounds. Then we go on to the second cross product. Again, second row is going to be that same ROA in this case, 3, 3, -2. But the third row is going to be the components of F2, which we were provided as -10, -30, and 50 pounds. Those are the two forces that act that don't pass through the origin. So if we add their effects together, we're going to get the net moment around point O in this case. All right, so take a couple minutes and expand these out so that we can get the moment in its I, J, K components. All right, so we want to expand this the same way we did the last one. The J, -2, 20, 30. All right, so we expand the I, the J, and the K from the first, and then we do the same to the second. All right, Since we have two cross products, we do have a total of 6 terms here that we do have to write out if we're doing this kind of the long way here. So for each one, we have to figure out what it's going to be. Right, so we're going to get 90 minus negative 20. We'll get here 90 minus 40. We'll get 30 minus negative 60. We'll get 150 minus a positive 60. We get 150 minus 20. And we get negative 90 minus negative 30 or plus 30. Right, so since we have a coefficient in front of I, a coefficient in front of I, we're going to be able to simplify this down into just a single term in front of I, in J, and K. So what we should get in totality then is that the net coefficient in front of I, 110 plus 90 gives us a positive 200I. Negative 50 minus 130 gives us that negative 180J. And we get 90 minus 60 gives us, 90 minus 60 gives us a plus 30K. Again, the units are going to be feet times pounds. So pound feet or foot pound, same thing.